Good morning. Thank you. Thank y'all for having me here. We were talking outside. The last speech I made was Sunday at the Baseball Hall of Fame induction ceremony. Is this a cool job or what? The only way I got on that stage was the U.S. Navy. Athletic ability, I wouldn't have gotten in the same state. CSBA and Booz, thank you so much for hosting this very important event and perhaps overdue event. The Department of the Navy is a leader in how we use energy, both as a resource and as a weapon. And as we continue the pursuit, the deployment, and the advancement of energy use, and specifically, as y'all are meeting about, and I'll talk about today, directed energy technology, we intend to add more promising energy capabilities to the long list of innovations that make the United States Navy and United States Marine Corps what they are today, the most powerful expeditionary fighting force the world has ever known. Our Navy and our Marine Corps uniquely provide presence around the globe, around the clock, ensuring stability, deterring potential adversaries, and providing our leaders with options in times of crisis. We're America's away team because of the ability of sailors and Marines, equally in times of peace or war, not only to be in the right place at the right time, but the right place all the time. We get on station faster, we can stay longer, we bring everything we need, and we don't have to ask anybody's permission to get done what needs to be done. Our ability to provide that presence is built on four fundamentals. People, our sailors and Marines, and their innate ingenuity. Our platforms, the numbers of ships and aircraft and weapon systems. Power, how we fuel those platforms and how we use energy defensively and offensively. And partnerships, our strong relationships with industry, with our international allies, and most importantly, with the American people. The advantage we have in each one of these areas and the forward deployed nature of the maritime services make our Navy and Marine Corps absolutely the best. But the superiority, both in terms of technology and concepts that we enjoy today in all domains, over, on, under the sea, didn't just happen. There have been more than 2 centuries of collaboration and experimentation among people in and out of uniform, with industry, with academia, defining and redefining what's possible. In so many cases, together we have taken impossible ideas, or ideas that people said were impossible, and made them real. And nowhere is this more true than in the field of energy. Now, any of you who've heard me speak know that I use this history. The Navy and Marine Corps pioneered energy transformation in this country, from wind to coal, coal to oil, and the use of nuclear for transportation. We relied on our people like Admiral Hyman Rickover, who partnered with General Electric to put nuclear power on our platforms. And today we have them on all our subs and carriers. Today we're using hybrid electric drives on our ships and advanced biofuels in our aircraft and our ships. We're experimenting with different kinds of fusion reactors and with creating seawater-derived fuels for our unmanned underwater vehicles. We're harnessing things like solar and wind at our bases. And by the end of this year, we're going to have 1 gigawatt of alternative energy on our bases. That's 50% of all the power that we use. The goal was to have that by 2020. We're going to get it done 5 years ahead of schedule. And by doing that, we're denying our adversaries the ability to use energy as a weapon against us. You don't have to look any further than to see what Russia is doing in Ukraine or what Russia is trying to do to Europe to understand how energy, directed or not, can be used as a weapon. And until recently, we've been vulnerable on this front. Here, in fiscal years 11 and 12, that vulnerability was shown when nearly $3 billion in unbudgeted fuel price increases came into DOD, the result of unpredictable and volatile oil and gas prices. This unfunded bill, and it was unfunded in the year of execution, impacted training, impacted operations, and ultimately could have impacted national security. Our shift in the Navy and Marine Corps to alternative energy has decreased our dependence on fossil fuel, not only saving us money, but more importantly, saving us lives, giving us a strategic advantage against those whose ability to fight is contingent on oil. But our focus in Navy and Marine Corps has never been on just harnessing power for propulsion or consumption. In the 1870s, Albert Michelson, very first American to win a Nobel Prize in physics, who, by the way, at the time he won, was an instructor at the Naval Academy, first measured the speed of light. Since then, Navy and Marine Corps' continued advancement of STEM, our harnessing of the electromagnetic spectrum, have led to defensive and offensive systems like Aegis, the electronic attack suite on the F-18 Growlers, and laser-guided precision munitions. And we've extended that leadership to the development of electric railguns and deployable laser weapons. But I think it's also important to note we're not the only folks doing this. Some others, although more basic forms, are using this technology today. Just 2 weeks ago, USS Forrest Sherman, DDG-98, and her attached helicopters were repeatedly targeted by a laser from an Iranian-flagged merchant vessel. And last week, y'all read in the paper, 11 commercial airliners were targeted with lasers at an airport in New Jersey. These are examples of how the world is getting a lot faster and is changing exponentially. And unfortunately, that faster world, that more nimble world, all too often is with the exception of the United States military. A few months ago at the annual Sea Air Space Symposium, I talked about the importance of reinvigorating the culture of innovation that's out there, particularly in the Navy and Marine Corps, in order to kickstart, to accelerate emerging operational capabilities, to get them from the lab to the fleet, to get them from naval research and development enterprise into the hands of the warfighter quicker, faster, more efficiently. And an example that I'm going to talk about today is the electromagnetic railgun. It's going to be on a Navy ship, finally, next year. But only for testing, and only after several decades of development. That's just too long. So I've directed the Department of Navy to streamline in every way we can our acquisition process. Far too often, we've bound ourselves with rules and requirements have nothing to do with the ultimate outcome of getting something to the warfighter and everything to do with protecting bureaucratic fiefdoms. So I'm calling on stakeholders at every level of the department to bring me solutions. And I've created a crowdsourcing platform to get the best ideas from the fleet to the decision makers, uninterrupted and unhindered by administrative chains. I applaud the efforts from so many sources to make the acquisition process simpler and faster, to remove some of those bureaucratic obstacles and layers, and to prioritize responsibility and accountability in the process. If we don't free ourselves from the ever-expanding, ever-tightening coils of bureaucracy, if we don't set the pace on adopting change, if we continue to think and do in the same ways by not being intelligent users of energy in all its capabilities, then our days as a preeminent force in the world are almost certainly numbered. And we can and we will lose. Now, I think in this room, safe to assume that you believe, as I do, that losing just isn't an option. So this morning, I'd like to tell you a little about what the Navy and Marine Corps are doing to stay ahead of that curve. How our military, our industry, and the American people, I hope, will benefit. As I mentioned, the Navy has always been a leader in energy, and directed energy is no exception. We built the first megawatt class high energy laser called Miracle, mid-infrared advanced chemical laser, in the 70s. And we tested it with the Sea-Light beam detector in the 80s. In 2012, a prototype laser was temporarily installed on the flight deck of the USS Dewey and successfully shot down 3 UAV targets. In 2014, we deployed the first operational laser aboard the USS Ponce in the Arabian Gulf. Now, it's from these successes that I think I and Navy leadership recognize the potential utility and, by the way, cost effectiveness of directed energy weapons across the full range of military operations. And I established the Navy Directed Energy Steering Group. This oversight group brings together senior leaders from across the department, from technical experts to resource sponsors to warfighters. And my task to them was to develop a departmental strategy and roadmap that prioritizes relevant missions, draws on S&T, draws on R&D to support rapid and efficient acquisition of directed energy weapons. Deputy Secretary of Defense Bob Work approved the strategy in 2012 while he was serving as Undersecretary of the Navy. And I'm going to release the comprehensive roadmap this fall. This roadmap will chart our course for research, development, and the fielding of high-powered radio frequency weapons, lasers, directed energy countermeasures. And I'll follow it up with my guidance for the Program Objective Memorandum, the POM, for FY18, which importantly will establish a resource sponsor and a program of record. This defined pursuit of directed energy technologies are going to broaden the range of technical options for the warfighters, reduce cost, decrease response times, and create breakthroughs with commercial, non-military application for Americans in industries ranging from construction to medicine. And these tools provide a cost-competitive solution that have options. Because the variable intensity of directed energy gives commanders the power to choose whether to deter, disable, or destroy using the same system. The cost of a single laser shot from our laser weapon system, LAWS, on the Ponce is less than $1, compared to hundreds of thousands or in some case millions of dollars for current self-defense payloads. Railgun rounds cost about $25,000 each, compared to $500,000 to $1.5 million for missiles. And unlike conventional projectiles, directed energy weapons, as Michelson learned, travel really fast, speed of light. I understand that's pretty fast. High storage capacity batteries can serve us and Navy as magazines, but they can also be the source of power for items like cars and buildings in the civilian sector. Now, the applications for directed energy and the advantages are plentiful, but there are still obstacles to overcome. And the Department of the Navy, I would argue, is best positioned to address these obstacles right now. The size, weight, power, and cooling required by contemporary directed energy systems make naval vessels the platform of choice to operationalize this technology. Our ships are big enough to host large, heavy weapon systems. Our gas turbines can provide the magnitude of power necessary to make these weapons effective. And we've got all the salt water in the world and the air in its atmosphere for cooling. And since the size of the fleet is increasing, and we'll be at more than 300 ships by the end of this decade, there are going to be plenty of platforms to put these on. And because we're fortunate to have the world's largest amphibious force and second largest air force, all within our department, as we develop practical, compact systems, we can employ them immediately, undersea, on the sea, in the air, and on the ground. Strategically, as a maritime force, one that is perpetually forward, deployed to maintain that global presence, we're the one service capable of complementing the near instantaneous effects of directed energy weapons with near instantaneous response. Just look at the laser deployed on the Ponce in the Arabian Gulf. Not only has it proven its ability to withstand pretty intense heat, pretty intense humidity, a lot of the harshest elements you can find, it's proven that if it needs to, it can defeat small boats and UAVs. It only takes one sailor to operate it, and it's got a second use as a telescope. The Office of Naval Research is using lessons from the Ponce to facilitate our solid-state laser technology maturation program that aims to produce a 100 to 150 kilowatt laser prototype for at-sea testing by 2018. And we're seeing if we can shrink that timeline a little bit. Meanwhile, due to the exceptional capability demonstrated by laws on Ponce, we've decided to extend that deployment to continue utilizing it in theater. And now shifting from directed energy to electric weapons. As I mentioned, the railgun has been a long time coming. But despite the slowness in getting there, we've now successfully tested a 32 megajoule railgun. 32 megajoules, same amount of energy as the detonation of 11 pounds of C4. That energy accelerates a 23-pound projectile from 0 to 5,000 miles an hour, so Mach 7, in 100th of a second, and propels it more than 100 miles. And if you want to make a comparison, the Navy's current 5-inch guns have a range of about 13 miles. Its rounds weigh 100 pounds, and their explosive nature makes them more dangerous to store and to handle. Next year, we're going to test the railgun at sea aboard the high-speed vessel USNS Trenton and validate its use on a mobile platform. During that test, we're going to shoot 20 projectiles, 5 of them GPS-guided hypervelocity projectiles, or HVPs, at targets 25 to 50 miles away. The Department of the Navy is continuing to lead the way, and we see opportunities to work with some of our most important partners as we keep moving forward. So to our industry partners, we want to and we need to work with you to improve the efficiency of these directed energy and electric weapons. The smaller, the lighter, the cooler, the more energy conscious we can make them, the better. We also need some help in developing adaptive optics and other atmospheric compensation techniques to address the harsh maritime environment. And we need smaller batteries that store more energy. For the railgun specifically, we need materials techniques and manufacturing technologies to produce long-life barrel rails and projectiles that can withstand the extreme aerothermal effects associated with Mach 7 instantaneous flight. We need Congress to support the development of directed energy. But in all these, it's important to understand that while these weapons represent the future of warfare, they're not a cure-all. They're part of a whole. Directed energy weapons, very frankly, have developed a stigma of over-promising and under-delivering. I think we're fixing that with the weapons currently in development, and they're a key component of our suite of operations. Today, we're using these weapons to complement our conventional kinetic systems with a long-term goal of enhancing their capability and effectiveness against the most challenging threats that we have. But to do so, we need to maintain both our current gun and missile systems and integrate the next generation of weapons through retrofit and on new construction. And most importantly, we've got to work, and we've got to work together to eliminate acquisition processes that take years, because we're in a race that will be decided by nanoseconds. By embracing, supporting, enhancing directive energy solutions, we can break free of a process that simply aims to keep pace with a threat. We've got to stay ahead of the threat. Directed energy can go beyond its envisioned role as an offense and defensive tactical tool, and it can become a truly global deterrent. If we do this right, our fleet will employ 300 to 500 kilowatt lasers against over-the-horizon threats. We'll use rail guns, or we'll be able to strike at targets more than 100 miles away. And we will defend our people and our platforms with non-lethal things like high-powered radio frequency systems in every domain. A foreign chief of Navy once told me the difference between soldiers and sailors is that soldiers look down. They look at maps. They see borders. They see obstacles. Sailors look up. They look at the horizon, at what's beyond and at what is possible. Like our sailors and Marines, creativity, adaptability, willingness to take risk are the hallmark of this country. Now, we know the direction of this future, and soon we're going to have a roadmap to follow. But together, we've got to have the foresight and the commitment to make directed energy a strategic part of the new normal. So from the Marines, Semper Fidelis, always faithful. From the Navy, Semper Fortis, always courageous. Thank y'all. Who's got a question?
Mr. Secretary,
I have a tradition that all hands calls, first question gets a coin.
Okay.
So I'll leave it right here for you.
Thank you very much.
All right.
Mr. Secretary, Bill Sweetman of Aviation Week. You're talking about the importance of pushing forward development of directed energy in the United States. What's your sense, what's your assessment, what do you hear about development of directed energy elsewhere, and particularly in nations that are potential adversaries or potential adversaries' armorers? Do you think we are in some kind of technological race here?
Well, as I said, I'm absolutely positive we're not the only ones doing this. And given the advantages that these systems offer, I would be very surprised if lots of people weren't working on them pretty intensively. And I think we're always in a race to stay ahead of threats. I think we're always in a technology race to make sure that we stay ahead and that we have that technological edge. So I think it's true here too, but it's not just here. But if we are not careful, we can squander the edge that we have. We can lose that technological advantage and all the R&D and the S&T that has gone. Learned about things like the acquisition process, about getting these things out of the lab and to the warfighter.
You mentioned some of the acquisition reform measures you've taken in this area, the Directed Energy Council or steering group that you created, and that's going to actually lead to a product very soon with this, this POM and guidance. So talk to me about how you've actually changed the process in more detail, how you've sort of shaken things up to make this move faster than it would have under more traditional systems.
Well, I think the main thing is to have a focus on this as a cohesive whole, instead of program here, program there, stovepiped up, one for surface, one for air, one for lasers, one for railguns, one for this, one for that, and put a group in charge of, we're looking at all directed energy weapons here, and how do they fit into Navy? How do they fit into all our platforms? How do they fit into all our concepts? And that's the biggest change, Sydney, that is to get everybody in the same place, work through the process of, okay, here's a technology that's very promising. We're going to put resources behind it. We're going to put the things we need to do, and in the more traditional acquisition process, we're going to a resource sponsor, a program of record, so we can get these things going. And in that group is not just the R&D folks, and not just the S&T folks, and not just the acquisition folks, not just the requirements people, but also the people from the fleet, the warfighters. Here's what we need. So I think you're matching up in a way quicker way what do you got in the lab versus what do you need in the field. And so some of the technologies we may not pursue, because even if they were successful, the warfighter says it won't give us much of an advantage. And I think, so that's the biggest change from the normal acquisition process, where you get usually a one-off system that comes up through one community to fruition.
Sir, James Drew, Flight Global. You made the point, obviously, that the Navy employs the second largest air force in the world. Will this directed energy roadmap that you're working on, will that have a roadmap for airborne laser applications for your fighters?
It's going to be a roadmap for directed energy in every domain. So undersea, on the sea, above the sea, and on the ground, because we operate everywhere, and it'll all be a part of that.
Secretary Mabus, Andrea Shalal, over here, way
Oh,
over here.
there you are. Okay.
Sorry. I needed power, so it's all about energy, right?
Don't we all?
I was wondering about this program of record that you mentioned. Does that mean that you will it be sort of various different different weapon systems that are included in that, or are you talking about one specific program that would be included in that fiscal 18 guidance?
I'm going to give you a wait and see answer, Andrea, for the roadmap and then the POM that follows the roadmap. But the idea is to not concentrate on just one weapon system.
And then finally, I just want to ask you about the sort of further implications of this technology as you're thinking through larger scale programs that you have coming down the pike. To what extent will the gains and advances in this area allow you to offset costs in other larger weapons programs that you need? So, I mean, will you be able to make those trades further down, or are you going to commit yourself to a course of action on some of these other programs, whether it's, fighter aircraft or ships or submarines that, will not allow you to introduce these weapons then later?
Well, as I said in my talk, I think you've got to do these things concurrently. I think you cannot just focus on directed energy, that you've got to continue to do the more traditional kinetic versions, because we got so many out in the fleet right now. And I'll give you the example of aircraft. We don't like to have one generation of aircraft on the flight deck. No, we like to always be bringing in new aircraft to up capabilities, but not getting rid of the previous generation until that capability is fully developed and we have enough of the platforms. And I think the same thing is going to be true with directed energy. As these programs mature and as we know that they work, we know that we can get off enough rounds, we can get power fast enough, discharge it quickly enough, that it's enough power. Then you begin designing these weapons into new builds, and you also begin, as ships or aircraft or whatever come in for retrofit or for maintenance, you begin to put them on ships that are already in the fleet. But it can't be a one or the other type system, because we've got too much of the traditional kinetic things in the fleet today. We're very good at how we use those. We're good at developing those. And as we bring in this new generation, I don't think we ought to lose sight of what we have today or the need to stay current on that as well. Okay. Thank you.